I'm Patty Simpson with Simpson Math. In this series of videos, we're discussing parent functions. In this particular video, we're going to look at the parent function of a cubic function. So first, let me show you a few cubic functions. So a cubic function just has a third degree polynomial. In other words, the largest exponent in the function is 3. So here's an example of a cubic function. Another example of a cubic function would be this one. Notice again, if I were to multiply that out, the largest exponent on a variable would be 3. So the degree of the polynomial would be 3. So this is what makes a cubic function, is that the degree of the polynomial is 3. And the simplest form of that type of function is just y equals x cubed. Or in function notation, f of x equals x cubed. And we're going to look at the graph of that function. So first, let's talk about the domain of the function. In other words, our x values. Is there a real number that I put in for x that would give me something other than a real number for y? Is there any number I can put in for x that doesn't output a real value for y? Well, let's just do a few problems and just see, well, what about if I put in 0 for x? 0 is a real number there. Do I get out a real number for y?
0 times 0 times 0 is 0.
So if I put in 0 for x, I get out 0 for y. That's a real value. What about, say, a negative number? If I put in a negative 1 for
Negative
x.
1 times negative 1 times negative 1 is negative 1.
Good. So I get out a real value there for y. What about a fraction? Can I put in a fraction? Will I still get out a real value there for y if I put in a fraction?
1/2 times 1/2 times 1/2, that's going to be 1/8.
Because 2 times 2 is 4 times 2 is 8. So it looks like I can't think of a number that I can put in for x that I don't get out a real number for y, or no real number that I put in for x that won't give me a real number for y.
It makes sense that you can multiply any real number by itself 3 times.
So we say that the domain of this function is all real numbers. Or in fancy math talk here, set builder notation, x such that x is an element of the real numbers. In other words, x can be any real number. Or in interval notation, x can be any number between negative infinity or from negative infinity to infinity. It can be anything in there, any number. So because of that, I'm going to choose these 5 numbers to substitute in for x. I'm going to use -2, -1, 0, 1, and 2. So if I put in -2 for x, then my output is -2 times -2 times -2. A negative times a negative makes it a positive, times a negative makes it a negative, so I get out -8. 2 times 2 is 4, times 2 is 8. If I put in -1 for x, I have that same situation where I go negative times negative is positive, times negative makes that negative, and then 1 times 1 times 1 is all 1.
But it's
negative 1. And then if I put in 0, well, 0 times 0 times 0 is 0. If I put in 1 for x, I get 1 times 1 times 1, which is 1. And if I put in 2 for x, I get 2 times 2 times 2, which is 8. So these are the 5 points that I'm going to graph on this cubic function. So the points are at -2, -8. Remember, we walk first, and then we climb. -1, -1. 0, 0. 1, 1. And 2, 8. And again, the domain is any number. Our x values can be anything in between there. So it could be a 1/2, and we saw earlier that it was 1/2, 1/8. So we know there's a point there as well. So to show that, I'm just going to connect my points here to show that there are points all the way along. and it keeps going. So I put that arrow on there to let me know that it keeps going forever and ever. So there's our graph of our cubic function. For those of you who live in Temple, I always remember the shape of the cubic function because 3rd Street in Temple looks just like this. I drive down 3rd Street every morning, and I'm driving down this cubic function every morning as I pass by the taqueria and the where I pay my water bill and the new fire department and Jack in a Box. It looks just like this 3rd Street, so it helps me remember the shape of that graph. Be sure to label your points on your graphs. So 0, 0 is an x-intercept and a y-intercept, and I would label each one of my points on the graph so that my reader knows exactly what the points are and what the scale is that I've used when I'm graphing. So there's your parent function of your cubic function. Thanks for watching.